An object moves horizontally and follows an equation for its location and speed as a function of time in seconds as x of t equals 3t to the fourth minus 8t cubed minus 6t squared plus 24t, t between 0 and 3 inclusive. Determine the parts a through g. So our position function of time here is a fourth order polynomial, 3t to the fourth minus 8t cubed minus 6t squared plus 24t. For part A, we want to find the velocity as a function of time. The velocity as a function of time is the derivative of the position function of time. The first term is the power rule. Bring down the power, multiply it with the 3, subtract 1 from the power. The second term is the power rule. Bring down the power, multiply it with the negative 8, subtract 1 from the power. The third term is the power rule. Bring down the power, multiply it with the negative 6, subtract 1 from the power. And then the fourth term is a constant times t. The derivative will be the constant. For part B, we want to determine the time or times when the velocity is 0. And that's going to be found by taking the velocity function we just determined, setting it equal to 0, and solving for all t's that make that true. What we have here is a 4-term third-order polynomial. Since we have 4 terms, we can attempt to factor this using group factoring. Let's group together the first 2 terms and plus, and group together the second 2 terms. The first 2 terms have a common factor of 12t squared. If we factor that out, we will be left with a t minus a 2. The second 2 terms have a common factor of a negative 12. If we factor that out, we will be left with a t minus 2. Since those t's minus 2's match, we can factor the t minus 2 factor from the entire expression. So we have t minus 2 multiplying. If we remove these from here, we will have 12t squared minus 12. Now 12t squared minus 12 has a common factor of 12. We can move it to the very front, in front of the t minus 2. But if you factor it out, you'll be left with t squared minus 1. T squared minus 1 is a difference of squares, and so it can factor into t plus 1 and t minus 1. With that being equal to 0, we end up with a t being a 2 or a negative 1 or a positive 1. We do not want any negative times, so we will keep only t equals the 1 second and t equals the 2 seconds. There's the 2 times where we will have a velocity be a 0. Those can potentially be turnaround times for the position function, where it changes the direction that it's moving. For part C, we want to find the maximum horizontal location reached, and for part D, we want to find the minimum horizontal location reached. These will be potentially at the initial time, that's up here, the 0. Any of the turnaround times, or times when the velocity is 0, we found those here. Or it may be the final time, that again is here, and that's a 3. To determine where it's going to happen, we're going to find the position at each of those times. The initial time 0, the turnaround or 0 velocity time of 1, the turnaround or 0 velocity time of 2, and then the final time of 3. Let's find the position at 0, the position at 1, the position at 2, and the position at 3. These are found by plugging the times into the position function. So x of 0 will be 3 times 0 to the fourth, minus 8 times 0 cubed, minus 6 times 0 squared, plus 24 times 0. 0 to the fourth is 0. 0 cubed is 0. 0 squared is 0. And 24 times 0 is 0. 3 times 0 is 0. Negative 8 times 0 is 0. Negative 6 times 0 is 0. Plus 0. These add up to be 0. We're in units here of feet. there's the initial location. It's at 0 feet. Now we will plug in a 1 for each of the times. And this will determine where it's at a time equals 1, which is our first time of 0 velocity. And it may be a turnaround time. 1 to the 4th is 1. 1 cubed is 1. 1 squared is 1. And 24 times 1 is a 24. 3 times 1 is a 3. Minus 8 times 1 is a minus 8. Minus 6 times 1 is a minus 6. And then plus 24. 3 minus 8 is a negative 5. Negative 6 more will make a negative 11. Plus the 24 will be 13. So it'll be at a position of 13 feet. X of 2. Plug 2 in for each of the times. This will be the position at the second turnaround time or 0 velocity time, 2 seconds. 2 to the 4th is 16. 2 cubed is 8. 2 squared is 4. And 24 times 2 is a 48. 3 times 16 is a 48. Minus 8 times 8 is a minus 64. Minus 6 times 4 is a minus 24. And then plus a 48. 48 minus 64 is a negative 16. Minus 24 more is negative 40. Plus 48 will come out to 8. As we see, it's actually moved backwards because it was at 13 feet, and now it's back at 8 feet. And now, at the final time of 3, plug a 3 in for each of the times. Three to the 4th is an 81. 3 cubed is a 27. 3 squared is a 9. And 24 times 3 is a 72. 3 times 81 is 243. Minus 8 times 27 is a 216. Minus 6 times 9 is a 54. And then plus the 72. Now 243 minus 216 is 27. Minus 54 is negative 27. Added to 72 will be 45 feet. So now it is turned back around and moved from 8 in the positive direction up to the 45. For part C, the maximum horizontal location reached, x max, it's going to be one of these 4 up here, whatever is the largest. And that turns out to be at the final time of 3, and it's at 45 feet. The minimum horizontal location reached for part D is the minimum from up there, and that happens to be the 0 feet. And that occurred at the initial time. Part E, we want to find the total displacement of the object. What the object is doing here is it's starting at time equals 0, and it will be at 0 feet. And then it's moving, and at time equals to a 1, it is now at 13 feet. Now it's turning around because it's going back to 8 feet. And at time equals to 2, it'll be at that 8 feet. And then it's turning around again. and at time equals 3, it's at 45 feet. Displacement is the distance between where it started to where it finished. And it's found by subtracting the final, which is x of 3, minus the initial, which is x of 0. Now x of 3 is a 45, x of 0 is a 0, and 45 minus 0 is 45. And so it ends up 45 feet away from where it started. The total distance traveled will be how far did it actually move altogether. And it's going to move this piece here plus this piece here when it's turned around, and then this piece here, it's turned around again, and we add up all of those distances. We want to make sure they all stay as positive numbers, and so that's done by the final position minus the turnaround time before it, plus that turnaround time minus the turnaround time before it. We have two turnaround times here. And then add to that turnaround time minus where it started. And take the absolute value of all of these. That will make all of them be a positive number. Specifically this one here where it's moving in the negative direction, this small piece in here, that one will become a positive in the absolute value. This middle one I expect to be a negative number because it's moving leftward there. The other two should be positive numbers, but the absolute values will ensure everything's positive, and it will total up to the distance. So that will give us the absolute value of, well, x of 3 is a 45, minus x of 2, which is an 8, plus x of 2, which is an 8, minus x of 1, which is a 13, plus, and then x of 1, a 13, minus x of 0, which is a 0. So 45 minus 8 is 37. 8 minus 13 is a negative 5. There's the negative expected while it was moving to the left. And then plus 13 minus 0, which is a 13. We want the absolute value of each of these, so it'll be 37 plus 5 plus 13. 37 plus 5 is 42, plus 13 more is 55 feet. So it traveled a total distance of 55 feet and displaced 45 feet in doing so. And that's because part of the time it moved in the negative direction. For part G, we want the acceleration as a function of time. The acceleration function of time is the derivative of the velocity function of time, and therefore will be the second derivative of the position function of time. We have the velocity function of time in part A. We're going to take the derivative of that. The first term is power rule, bring down the power, multiply by the 12, subtract 1 from the power. The second term is the power rule, bring down the power, multiply with the negative 24, subtract 1 from the power. The third term is a constant times t. The derivative will be the constant. And the fourth term is a constant with no t. The derivative will be a 0. So our acceleration as a function of time is 36t squared minus 48t minus 12.